Houston, we are ready for lunch.
All right, geometry students, this is section 6-8. I have a picture over to the right. That is, I believe that's a spaceship Endeavor or spaceship Enterprise. Um, this is what the date in history, the famous date in history for I think it was the spaceship Endeavor was around this time for when it first launched, and I think that was the one that went up into space a bunch of times. And I was just thinking about this because I love space movies. I have Apollo 13. That's a really good one. That's an older one. But The Martian is the one that just came out recently. Um, I like that one too. But anyway, let's get to some math. Our goal for today is to name coordinates of special figures by using their properties. Um, and this, so the theme for this is applying coordinate geometry. We just talked about last section about some different ways you can use uh, you can prove things or check the type of shape based on the midpoint formula, the slope formula, or the distance formula, and combining that with the properties. Now we're going to take it a little bit farther, and we're going to talk about how we can use just general coordinates to prove things, or just to do things and to talk about properties, and then the next section is going to be dealing with proving things using this coordinate geometry. So, um, the first question, this is in your notes, I believe it asks, would you think would be the best placement of a triangle in its mid-segment, and why? So if you look at the three figures, which one do you think is the best or the easiest to work with then if you're dealing with the different formulas? Now, I'm going to go with figure 2, and here's my reasoning. I would say figure 2 just because it has a something on the origin. The origin is great because they're both zeros, and when you're adding or subtracting or multiplying by zeros, that makes things easier. We also have another point R has a zero in it as well. Now, figure 3 is alright too. They all each have a zero in there. That's why I'm thinking figure 3 is decent. Figure 1 is not the best. It has all different points. Though it's doable. It's definitely doable. It's just going to make more work for yourself. So I'd pick either figure 2 or 3. But we're going to talk about why. We're going to talk about different things for what we're going to talk about for coordinate geometry. So here's some tips, and you'll see why these are useful in a bit, but tips for placing a figure on the coordinate plane. So the first step is place at least one side on an axis. So if you look up here, um, both figure 2 and 3 have one side on an axis. So it has zeros, and it's going horizontal or vertical. It says, or center the figure at the origin. So if you have it centered at the origin, that's helpful too because you're working around 0. Anticipate what you need to do in the problem. So again, placing it 2 or 3 might be better just based on, depending on what you're doing in the problem. One might be easier than the other. And then lastly, multiply the coordinates by the appropriate number to make your work easier. All right. So multiply the coordinates by the appropriate number to make your work easier. So part of that has to do with um, whether you are dilating it, whether you're moving it, um, or just making it so you don't have all decimals or fractions to work with. That would make it easier. So you can use coordinate geometry and algebra to prove theorems in geometry. This is called a coordinate proof. We're going to do more of those in section 9. All right, so some examples to talk about. First of all, example 1. What are the coordinates of the vertices on each figure? So number 1, you're given the rectangle has a base of 2b and a height of h. So that's all you're given. And you're given the points labeled. We're not given numbers. We're just given variables for what the height and the base are. So if the height is h, that means it goes up all the way to h. So we know that the y-coordinate for both a and b are going to be h. And the y-coordinate for both b and c, or d and c, are going to be 0. Um, the distance is 2b right here. So then each part on each side would be b. So this is b, and this is b. Or negative, I guess, going over negative b. So I guess if you're saying the point A, left you're going negative b, and you're going up h. Interesting. No, it doesn't matter what the we don't know exactly what the distance is. We're just representing it with b and h. B would be over positive b and up h. C, which is over on the bottom right, would be over b and up 0. And then D would be over negative b and up 0. So there's the coordinates for each of those vertices. Now we have a parallelogram with height A. So this height goes up to A. And point P distance from B from the origin. P, point P, is B away from the origin. So this right here would be B spaces. So we go all the way to B. Alright, so we want to find the coordinates. And we have 0, 0. I'm not sure if that's supposed to be coordinate 0, but that's going to be 0, 0. Coordinate P goes over B and up 0. How do we know what coordinate Q is? As the height of A, so we know that both N and Q are going to have going up A. So the Y value there is A. So what I'm going to do is add another variable and say that N is N distance away. So this would be N and A. And Q would be B plus N and up A. Alright, let's go to number 3. We have an isosceles trapezoid with the base centered at the origin. We have bases of 4A and 2B. So we'll just say that if this is 2B, this is going to be B, and this is B, or negative B. And if up on the top is 4A, we'll see. So this would be 2A. This would be negative 2A over. And the height is C. So if we go up, we have L, and let's just start at L, J, K, L, M. We'll do J. J would be negative 2B. There's a negative 2A, sorry. And up C. K would be positive 2A and up C. L would be positive B and up 0. And M would be negative B and up 0. So again, we're just representing things with variables, seeing how this can work. And we're going to skip number 4 for right now. Oh my goodness, what's going on here? We're going to go to number 5, planning out a proof. So let's see what we have here. What is going on? It says, I don't know why that keeps happening. I'm so sorry. My computer has a mind of its own. Now stay. Alright, plan a coordinate proof to show that the parallelogram is a rectangle. So name the coordinates of it says name the coordinates of parallelogram ABCD at the right with base B and height H. So this goes up to H and H. This would be B. So our coordinates are A is 0 over and up H. B is B over and up H. C is B over and up 0. And then D is 0 and 0. Right, the given and proof statement. So we're given parallelogram ABCD with base B and height H. And we're trying to prove that parallelogram ABCD is a rectangle. So we're definitely going to have to use these coordinates when we're proving it. But C just asks, what information do you need to prove that the parallelogram is a rectangle? So think about what you need. That's one of the things that I said was a tip. Anticipate what you need. And in this case, we need to know opposite sides of parallel. Well, actually, we do know that. It's a parallelogram. Um, we just need to know that all angles are 90 degrees for it to be a rectangle. That's all we need to know. All right? So we could probably use the slope formula. But we're not going to do that right now. We're going to do a couple examples here. That's what we'll finish up with. Give the coordinates for point D without using any new variables. So this is an isosceles triangle, meaning this is congruent to this. This angle is congruent to this angle. And this is bisecting the side and the angle, so these sides are congruent as well. So we would be going over positive A and up 0. Let's look at number 7, parallelogram. We want to figure out D. So if this is B over, so this would go over B. This would be all the way over to A. So this would be right here would be A plus B. And so and then it goes up ahead of C, it looks like. So D would be A plus B and up C. So look at this one. We have a square, even though it looks like a diamond. It's just rotated. We have all the points A, B, C. Let's look at point D. This would be over A because this is also over A. And up, let's see, we go up C. This would divide it in half, so it would be 2C. There we go. And the rhombus. Based on the rhombus, we just know that they're parallel. We know that all the sides are congruent. We don't know. We know the opposite angles are congruent. But let's look at what D would be. We're going over 0, so the X should be easy. And if we're going up, these bisect each other, remember? So if we go up 2A to get here, we'll be going down 2A, so this would be negative 2A right there. And that's the last one we're going to do. So this section is really just all about kind of figuring out how you can place things on a coordinate grid to prove things about it. We're just doing general things, not specific examples with numbers, just general with variables, how we can prove things, and how we can label or use or find the coordinates of certain points on a coordinate grid. So what I'd like you to do now, and you can ignore this homework for right now, because it's going to change, I think. But answer the closing questions. It says a rhombus QRST is centered at the origin with QS equals 4R and RT equals 4T. Figure out what are the coordinates, whoops, what are the coordinates of each vertex. Alright, and that is it. So let's end this mission here by looking back at the goal and thinking about it a little bit and self-assessing on your goal sheet. Have a great day.